Alright, time for a new filament. So this is FilaCube. We've used that before, but it's a new color. I'll show you what color it is. Burnt orange. This is an unusual color, but it's going to work for what I need it to do. And that's the first use of it is going to be for printing out the terrain of Mars, where the new rover's landing. So I've used FilaCube before, and in fact, speaking of Mars, I did using the black FilaCube for my black parts of my Mars Ingenuity helicopter that I'm selling on my Etsy store. You can find a link to the Etsy store below. And I'm using the gray, making my Millennium Falcon dice tower. So you put dice in the top and they come out over here. So I had good luck with FilaCube. It's made in the United States. It's nice. It's a couple bucks more expensive than some of the other stuff, but it prints really nicely. I'm not expecting anything unusual with this, but I'm going to do another, for the fun print, I'm going to do something else I can use for outreach, astronomy outreach. So I'm going to go ahead and show this one. And it's been a while since I did one of these, and we want to see how the new printer is working. So after about a year and a half of printing, maybe 6 days a week for 10 to 15 hours a day, my old printer kind of wore out. So I got a new copy of the same one, and it's printing like a dream, because now, instead of me being a beginner, I would call myself an expert. So I know how to do the bed leveling super well and so forth. So it's basically printing perfectly. Anyway, so we had a good nice vacuum on this, like all the FilaCube stuff, and it's got a silica gel packet that we'll save. Add to our dry box for extra buffering. Let me get a better look at this color. So it's not bright orange. It's got kind of I think it's got brown in it. So it's going to work great for what we need it for. And we're going to do the usual stuff. It's getting into the fall now. It's September. So we want to see how the conditions in the garage are doing. I've been putting most of my filaments at 225, which is higher than one of these. This one actually goes up to 230, but even in some of the other filaments that say 220 max, it seems to work better with 225. Things flow better. The layer adhesion is good. I'm using 100% cooling now because it's not the winter time. And this is bed temperature up to 40 to 50 degrees. I've been using mostly 40-degree bed temperature for everything too, so I'll be doing that. So we're going to do a temperature tower and the bed level, bed adhesion and layer cracking test just for completeness. And then we're going to do a fun test with something I can use for astronomy outreach. And I may put it on my Etsy store. We'll see. I'll probably just put it on there for fun, see what happens. So we're going to weigh this up and see if we got our money's worth. All right, so we can weigh this up just by putting it on the scale. And we'll see how many grams we got that way. This, of course, includes the reel, which, it's usually about 150 grams or so. Depends on the manufacturer. So a better way to do it is to, if you have printed with this filament before, is get save one of their old reels. So I always save at least one empty reel of every filament I'm using. So you put it on here and then tear it back to 0. So that's 0. Now when I put the full reel on here with the reel, we got exactly what we got. So we got 1.014 kilograms. So that's good. We got more than we paid for, slightly, which is great. It didn't short us. So usually FilaCube is about this weight. So I would say they're accurate in their measurements. So. All right, let's put this on the printer and we'll do our temperature tower, pointing temperature tower. So here's our temperature tower project in OpenSCAD. There's a link to this in the description. And so we start out with every filament. And you just go over here and edit the starting temperature, which is the temperature at the bottom, and the ending temperature, which is the temperature at the top, and the step. So we're doing every 5 degrees from 230 down to 210. That's pretty standard for PLA, at least on my printer. Lower than that doesn't work as well for whatever reason. So I've just called this PT pointy temperature tower FilaCube.SCAP because we're pretty much printing everything at similar temperatures now that our printer's dialed in. So I don't think we need to have separate ones for each filament. Of course, we like to test each filament just to make sure there's nothing strange about it. So, all right, so we'll put this over into Simplify 3D, and then we'll set up the project to print this out. All right, here's Simplify 3D. So we imported our STL file. Now we need to set up our temperature gradient so that it matches that. So we're using a bed temperature of 40. That works really well for all the filaments we've been using, PLA filaments we've been using, and also for that printer. And then here's our temperature profile. So the first layer, which is the bottom down here, temperature is going to be 230, and then up through layer 18, which is right at the top of this bridge. And then above that, 230, layer 18 is at the top of this base here. Then up to layer 52 is the top of this bridge. At that point, we're going to switch to 225, which is what we have here, and so on up to 210. So that's the beauty of Simplify 3D. It's easy to set up these temperature gradients in the program. You don't have to muck around with other things. So then we're going to prepare to print. Oh, and then we set up a profile for temperature tower FilaCube. So everything else was standard, default for PLA. So here's our project showing how it's actually going to print. It has 190 layers, and we can select that and use the arrow key to go down and see how it prints. So again, this helps you a lot if you're designing things to see how they're going to actually print when it goes on the printer. This has saved me so much time I can't imagine. All right, so this is going to take about 55 minutes. It's probably a little underestimated, but that'll be a good time to go check on it. So we save this to disk. When I first started, I was printing over USB, but I have enough experience now. I don't really need to print interactively anymore. Plus, I think there was some problems with the USB where glitches on the USB cable were causing the printer to stop and things like that. So it's just much more reliable to use a SIM card. Save this to a SIM card, and then we will print it on the printer and see how it turns out. Then we'll know what temperature to print everything else at. The spatula is also a link to the spatulas in the comments. Right, nice bed adhesion. Bottom looks super clean. Try some of the light here, a little easier. There we go. Bottom looks super clean. Good bed leveling, if I do say so myself. And let's take a look at these layers. So there's some drooping on all of them. This filament's really high quality, so you can print it at probably a number of different temperatures, but looks like 225 is good. It's as good as anything else. In fact, the pointy thing, it looks slightly better than these lower temperatures to me. And let's check the back. Nice smooth surface. This prints really nicely, like all the FilaCube filaments. Could print it at 220, but I think I would print it at 225. That's what I'm using for everything else, including the other FilaCube filaments. So looks good at 225. So now we're going to go on to the bed adhesion and layer adhesion and cracking test. That's a key test to make sure your cooling, your bed temperature is correct for good adhesion. We used 40, that looks good, so I'm going to keep that. And also your cooling is set up so that you get good layer adhesion between the layers. So your extruder temperature plus cooling equals how well your layers adhere. adhere to each other. Of course, the filament itself. All right, so we get that set up at those temperatures, and then we will give it a try. So here's our bed adhesion and layer cracking test. This one again is on Thingiverse for free, and there's a link to it in the description. This is one I made up. So the bottom portion tests how well your corners are going to be adhering to the bed. So that tests how well you leveled it, and also the temperature difference between the extrusion and the bed temperature. And then the layer test is when it prints this vertical section. This is a bunch of layers that are fairly thin cross sections. So if your layer adhesion is bad, this will crack when you flex it. If you can flex it pretty hard and it doesn't crack, then you've got your layer adhesion then dialed in. So that's a function of both your temperature, your extrusion temperature, and also your cooling. So we're using 100% cooling right now this time of year, so you can really tell if this works. So there's nothing to customize about it. If you want to put your own text in here, you could. There's just a text string here. So that's my channel, so I put that in there. It also tests raised letters and inset letters. So that also reveals other problems I've found. Like if you have a lot of blobbing or something on this, that means the temperature is too high. And then if these are slightly weaker than the other layers, so it might crack right here. So this is a great test. I love it. I do it every time. So we'll put this in. We'll send this over to Simplify 3D, and then we'll make a G-code file and we'll load it on the printer. So here's our bed and layer adhesion test project from OpenSCAD in Simplify 3D. And we set up a profile here. We just called it FilaCube. And based on our temperature tower, we picked 40-degree bed temperature and 225 for extrusion. And cooling, this is the default for PLA, and I've been using this all summer. Last winter, I cut down on the fan speed because I was having layer adhesion problems. So, but for now, it's fall right now. Fall's just starting. 100% seems to be working fine, so I'm going to stick with that. All the rest of these parameters are standard. I didn't really mess with those. So we'll prepare to print, and it's going to take about 53 minutes. And we'll write the G-code file to a SIM card and load it on the printer, and we'll switch to the time lapse. There's a little bit of a string from the last corner, but that's fine. When we turn on preheat, right? Then we're going to take this. We're going to move it up a little bit manually. Lettering looks super clean. Some layer lines in here, but hopefully that's not going to affect what we're printing too much. So I don't think that's a big deal. As long as the strength is there, we're good. Let's check the bed adhesion. Alright, so it adhered to the bed perfectly. And bottom is super smooth. The corners are all adhered properly. And we try squeezing it up. We got some blobbing there. That's interesting. I wonder what caused that. I haven't seen that before. Here's one of the last ones we did. Let's see this. Maybe the temperature is too high. Well, that's something new for me. I haven't seen that before. Some little cavities there. Strength is super good. Not sure what could have caused that. I mean, it seems like it's under extruded, but the temperature is fine. The lettering is super clean. This is shiny. Well, I'm gonna chalk it up to a one-time glitch for now, and we'll go ahead and print our fun project, which I'll show you on the Simplify 3D first. Okay, so our bed and layer adhesion test work perfectly. So we have everything dialed in for the extrusion temperature, bed temperature, cooling, and so forth. So our fun print, we're going to print this Kuiper Belt object. It's called Arrokoth, and this is about twice as far from the sun as Pluto. So this is called planetesimal. This is how planets are made. So small objects run into each other and stick either by gravity or just, stiction, let's call it. In any case, I downloaded a 3D file for this object that NASA published. It's open to the public. I'll put a link for that in the description, also a link to this article. And I loaded it into I had to rescale it, which I'm not going to go over that in this video, but I rescaled it so it would fit, be a good size and fit in my printer. And so this is about, let's see how big it is. This is about 61 millimeters this way and 94 millimeters this way, and about 15 millimeters high. So 61 by 94 by 15. So, it's just a few inches. I think it's maybe 5 inches this way, something like that. Is that right? 2.5. That's a little over 3.5 inches this way. In any case, it'll be a nice size to show it for outreach. And there are two pictures of one side of it, so we don't really know what the other side looks like. But it apparently is a flat pancake, two pancake-looking things that ran into each other. So we set up our profile for Arrokoth, and we used our temperatures that we liked from everything else, and also our cooling. That's all the work we did before for the other two projects. And we prepared to print, and it's taking about an hour to print. So for actual outreach, I'll probably print this twice as big. It'll be easier to handle. But for the test print, this is fine. And we'll see how that turns out. We'll switch over to the time lapse. Alright, still looks like it printed okay. On the string here, don't worry about that. Let's move it up. I'm going to look at it. See how it comes off. Came off nice and smooth. So you can see the layer lines on the printing here. Where's this string here? See the layer lines? I could print it at 0.1 millimeters. But for the purposes of outreach, this is fine. Give people an idea of what it looks like. I do have a 3D picture to use red and blue glasses to look at. Actually, holding it in your hand and seeing what it looks like by moving it around like this is better than looking with 3D glasses. So, alright, I like it. It's kind of cute. It's like a little snowman. Hi, I'm Arrokoth. Anyway, the burnt orange came out pretty much how I wanted it. I'm happy with the results, and we're going to go ahead and start printing stuff with it. Alright. If you like this video, please give it a thumbs up. Post a comment if you have any questions or ideas, and I'll try to respond. That's all for now, but more videos are coming, and if you want to see them, please subscribe to my channel and turn on the notification icon if you don't want to miss one. This is STScI signing out, and keep looking up.